welcome back. We are starting a new build tonight. Actually, we're starting a new build series, I should call it. This is called the Cheap Shit Build series, and like the name suggests, we are going to build some cheap shit. This is mostly stuff that you can get, kits that will get you into the FPV hobby for very little money. So my goal was under $200 for a 5-inch quad. So that's a full-size 5-inch quad that you can take out and rip around on a 4S battery. And that should be more than enough for most people jumping into this hobby to go and have fun with. And so I searched around. There's a bunch of stuff for under that $200 mark now. Getting under $100 is near on impossible. But the $200 mark, there's a lot of options, and one of them is the CL1 from Rotor Riot. They did a prepackaged kit where for $195 you get something without a receiver, so I could run Crossfire on it. Although today we're actually going to run an XM Plus on it because I'm all out of Crossfires and I don't feel like pulling one out of another quad. So we're going to run that today, and we're going to build this thing. And so the CL1 comes in a big box like this, and you get all your kit. You get some grip, which is actually really nice. You get a battery strap. You get your XT60 connector. You get what is this? Oh, this is the ESC and flight controller. I probably dumped them both into this box when I was looking something up. So we got an ESC and flight controller. Actually, this came with an XM Plus. So they threw one in, even though I didn't ask for one. I told them to send it without a receiver, but they threw one in anyway. And then you have the CL1 frame. Comes in a little baggie like this with some standoffs. You've got some camera gummies. So those will mount your camera. We've got an antenna for our VTX. So if you've never built a quad, this is actually a great kit to buy because it's got everything in it that you're going to need, besides things like solder and standoffs, and it may even have some of those things buried down in here somewhere. It's got a rush tank VTX, a great VTX. It's got the RunCam camera. Let's see, what do we get? We got, this is the RunCam Phoenix. So it can operate off of any battery voltage you throw at it, and it's an NTSC or PAL, so it's switchable on a menu. And it's got a 2.5mm lens, which basically means it's a 150-degree field of view or something close to that. And there it is. And, it's nice and blue. And then comes with a little baggie of screws and stuff, and then the 4 motors. And for the motors, and then that's it in the box. For these motors, these are Hype Train RR Rotor Riot 2306. So they are actually falling out of my hands. We'll just open one up. That way we can show it off before we really jump into it. I don't want to spend a ton of time on any one of these builds, but this is like completely disassembled, so you actually have to do some assembly on it. The other ones, we'll see. Like I said, I got the iFlight Nazgul, the M630, which is actually a 6-inch quad, and it was only $170 from Banggood. The iFlight Nazgul, I think, was $180, and it's really a good quad. And then this one was about $195, like I said. And yeah, so these are Hype Train motors. 2306 2450 kV, so perfect for 4S. All these quads are going to be 4S. So anyway, let's go ahead and get started. We've got might as well get our frame set up and get cracking. There's some standoffs. We'll set those aside. try and keep a clean, tidy workbench. Yeah, frame needs to go together basically first, at least the bottom part of it. And the frame comes with 4 individual legs, so if you break one, it's not a big deal. In fact, they came out a few days later after I ordered this kit and said, hey, for $10 we'll send you 4 6-inch arms. So if you wanted to run 6-inch arms, you totally could. And in fact, I actually have those arms down here in the thing, because I was planning on pushing this pretty hard and then, you know, giving it away sort of as a thing, but I've already got a taker for it, so it's not going to be a giveaway on this one. But the other 2 I'm going to see about giving those 2 away. And then we've got these little well, I say gummies, but they're not gummies, they're just foam patty feet for the motor arms here. And then those guys, throw all of this away. And it's pretty straightforward. You've got, this is your base plate, and this is the top side of the base plate. So your bolts will come up through and pull down like that. And then this is the absolute bottom of that. And so you have basically something that goes kind of like this. And then this guy goes on top like that, and your bolts go down through and screw into that base. And I actually think for 3030, it used to be, but I don't think it is anymore, that the 3030 holes were used to also mount your stack, but it looks like they've changed the design slightly in a later revision. But maybe it was an early alpha version of this had it set up that way. But nope, you can no matter what you do, you can access your stack just fine through these large openings here, here and here. This is your mounting hole, and this is your mounting hole, these 2 smaller holes. So this big one here are so that you can get to the heads of whatever flight controller stack you're putting in there. So, and it has provisions for 2020 or 3030, and then you have an additional 2020 in the rear that you can put in. Now the standoffs for the rear are really close to this 2020 mount, so if you're planning on putting like an ESC back here or something else, pretty much forget about it. It's going to be real close to those standoffs, real close. I mean, like, probably not going to work close. Just telling you now. People have tried and come up blank. So I think these are 10 millimeter. I just finished charging up a 6S, so I was going to try and fly a Mr. Steel build today. So, alright, there's that. These are coming down through here like so. Nope, goes like that. Yeah. Pretty straightforward to build, honestly. It doesn't require, you don't ever have to have done this before in order to do this. And it's really not all that complicated a build. Great beginner build, honestly. In fact, it was my first 5-inch quad, and all we're doing is getting them started. Basically, we're not snugging anything down yet, so that arm is still loose there. And then next one comes in. Nope, you just got to make sure you line up the holes so that when it goes into the slot, you have access to get the bolt through. And yep, like that. Get it started. Yep. Wrench this one around into place. Get it started. and really it's a very nice little quad. I like how it flies. I like how I own 2 of these. One, the HD1, which is basically the same thing but with slightly different standoffs to accommodate the DJI system. So, and I have an analog one that I have, which, like I said, was the first one I ever built, and it still flies great. So, and I only put it together a couple months ago. It was either that or a TBS Source 1, and I decided to get them both and see which one I kind of like better. And the CL1 went together so easy and so simple that I just never even bothered building the TBS Source 1. It's still over here in my box. So there it is. That is the bottom plate. From this bottom plate, the rest of our build can continue, and we're going to get our flight controller, or I'm sorry, our ESC in next, and that will position us so that we have just going around making sure everything is snug. Doesn't need to be super tight. There we go. There it is. There's the True X, CL1 there, and this is the rear, the one with 4 holes, and this is the front, as I recall. So yeah, that's how it goes. It goes pretty much like that. You got 8 standoffs to bring this up. About these are 30mm standoffs, as I recall. Yep, 30mm standoffs. So it comes up a little more than an inch. So you got plenty of room for a flight stack or whatever it is that you want to have inside there. And like I said, it's a really good build. The next, let's get our ESC figured out. This is the ESC right here, and this is the flight controller. And it's an F7, so it's going to fly great. It's got it's a 32-bit flight controller from HDLRC, and should fly pretty well. The thing to note about this flight controller, so the right next to this connector, it has a listing of the pins, and for whatever reason they chose not to make the motor pins sequential. So it actually goes from the very top of this connector. We have current and a TX, right? TX is for your telemetry, okay? And then you have S2, S4, S1, and then S3, S being the signal wire for motor 2, motor 4, motor 1, and motor 3 in that order. Don't ask me why they did it this way. And then you have a positive and negative battery that's going to feed your flight controller. So moving right along, we want to grab our stack bolts. These are good. They're hex. I wasn't sure if these would be hex or not, but it looks like they are. We run the hex bolt straight up through. Make sure you put it in the 30 by 30 hole. Okay, it'll actually only fit in the 30 by 30 hole because the 20 by 20 hole is 2mm, which is okay. It's a little old school now because a lot of 20 by 20 stuff is going 3mm as well, just because of the strength, the additional strength there. And we're going to run both of these up through there and get our, and I'm just kind of holding it on the top side and getting this nut started, and then it's going down, and I'm just snugging it up by hand. I'm pulling on the shaft, and that's what she said. I'm pulling on the shaft here and just tighten down by hand, just finger tight, and the yep, just go down through all of them. That should get us to a point where we can start actually putting the flight controller in. So it's a very, very simple build if you know what it is. If you kind of have done a build before And if you haven't, it's not that tough, really. The things to watch out for: don't tighten things down, right? I have things that are you saw I left this loose until I had them all 4 in place, okay? And then I kind of snugged them down because I knew I was going to have to move them again, right? Now with these, I have them in there, but I don't have them like super tight or anything. They're just barely in there, and I can loosen the map with a pair of needle nose pliers if I need a little bit of wiggle room or something else, because inevitably what's going to happen is this flight controller or this ESC is just not going to sit perfect on there or do exactly what we want. So the best solution for something like that is to make sure that you don't lock yourself in to one you know, to having to force something down on there. You just want it to be nice and loose, or easy to go on. You shouldn't have to force anything, at least not at this stage. You know, we're just getting started. If things aren't fitting, loosen it up. Just loosen it up. We can snug it down later. And what I'm doing here is I'm installing the gummies. The gummies we use here, these are just, we have gummies as well for the flight controller, these green ones in this pack here. And these gummies will just keep us the vibrations down from, you know, the you've got 4 spinning motors with props and other things on there. It generates a lot of vibration, so that's all these are doing, is keeping the vibrations away, and that's going to save your components and other things and keep you in the air a whole lot longer. I mean, you know, like I said, for a first quad, this is a great little flyer. And alright, so there's usually not an orientation to ESCs, but it makes it a whole lot easier to figure out where motor 1 is, because in Betaflight, or Betaflight is the software that drives your quad. Motor 1 is right here, so it's 1, 2, 3, and 4. Did I say that right? Is that right? 1, 2, 3, and 4. Yeah. And so what you want to do is try and make sure 1 is here, 2 is here, 3 is here, and 4 is here. Although it doesn't matter. It doesn't actually matter at all. Okay, so here are some numbers. There's 2 and there's 4, and that means that that one is 1. So we're going to make sure 1 is over here, and now we have an orientation. But if you screw it up, you can change it in Betaflight. You just go in there, you resource map, and it's not that tough, and there's plenty of YouTube videos on how to do it. Now let's go ahead and get this guy all tinned up. And what we're going to do is tin up all of our pads here with solder, and that's going to make it so that we can attach our wires a whole lot easier. And we don't need a ton of solder on these guys. Don't be afraid. I have my iron set at 400 degrees, and all I'm doing is I'm wetting the tip and then getting the tip on there, and that extra solder on there is acting sort of to conduct heat into the pad. Now you don't want to stay on there forever. You just want to get on there, add a little solder right down on top. Yep. Shouldn't take you but 2 or 3 seconds to do each one of these pads. And then you see how it's turning a little bit black there. It's kind of hard to see, maybe, or not in focus, but it's getting oxidized. That's what that brown is there. What you want to do is clean it off with a little one of these, and then get a little bit more on there, and come on down, and yep. Now you don't need a ton. I've got little tiny balls on there, just about perfect. And we'll see when we start attaching our motors exactly what we're doing there with that. Now the hard part in this build, first let's tin this guy, because this is another important thing to do. You'll notice that there's already tin on this wire. Don't be tempted to use it. That wire, this wire has lead-free solder on it, most likely. It's not always, but most likely it has lead-free on it. And that stuff does not like to melt, okay? So get a little bit of your own on there, okay? Just like that. And that will help make your life a whole lot easier. Yep. So just reflow it with some leaded solder, because lead-free solder is no fun to use. Now we've got positive here and negative here. We're going to do the positive pad first. Keep in mind, in positive, this will probably heat up faster than the negative. And the negative has a lot more thermal mass behind it, and it takes a bit more to get this guy nice and hot. But that one's done, and then now the negative one, we've got to really feed the wire into that, get it nice and hot. There we go. And the reason why is that entire PCB that's under there, printed circuit board that's under there, has a negative grounding plane, and that thermally conducts heat away from the pad. So when you try to get down on it, it really doesn't want to go, and makes it hard to stick things on. So now we're just going to come in here, and we're going to get our, yep. Okay, now that's not a very good joint, not until you come in and you come up behind it. Once you get it stuck on there, you can come up behind it and then just feed in some solder and reflow it, and just lift it up and away, and that looks a whole lot better. So stick it down and then get in there with a little bit more solder and reflow it all, and that will give you the best joints that you can ask for. And it's important to get these, especially because these are conducting the electricity from your battery to your quad, and you want the best connection you can get. There we go. And that's it. There's our flight controller pretty much set up and ready to go. This will connect to our battery, and we are rocking and rolling here. So we have this little guy, and we have this little guy. So I know we talked about our pins and how we have them mapped. One of the things we need to ensure on our flight controller here is that we don't just blindly connect our headers, these 8-pin headers, between here and the flight controller, because they're not standard. None of them are standard, but you can take the pins out and reassign them however you like. So it's real easy to just lift up a tab with the end of an X-Acto knife and slide the wire out, move it to the right position, and slide it back in, so that you don't have to redo any cabling or soldering for that matter. So this guy has R3, and that connects up to our T3, current 4321, positive and ground, and that's written in very, very small print right here on this connector. So what we need to do is pull apart our connector. Let's see here. We have this guy, and we have this guy, and we have, let's see, this is a 10 and this one is an 8. So the very nice thing about this is that they give you plenty of extra. So what we're going to do is we're going to, since this guy here is already configured for our flight controller, we're just going to remap everything here as we plug it into this guy. So that is boring and not much fun, but we should double check that which way is up, like this. Okay, so this is the correct orientation of this plug. Now we're going to take and connect up the very first one down here is bat, and this guy needs to go in like this. Yep. Yeah. So the orientation, it's got on the top side, you can kind of see there's this little barb, and that needs to go down on this connector if you're doing it like I am. Okay. And it might actually be a little bit difficult to get in that way, so you may need to unplug it and kind of, there it goes. Yep. So now we have it clipped in, it doesn't want to come out. And then the next one in line, now that we have it set up, we can kind of just use our board as a reference. The very next one over is the we're going to orient ourselves off this red wire, the battery positive. The next one over is the negative. So we're going to plug that one in, and that one's done. Now we have S3, so we need to find S3 out of these 4 purple wires. And so on here, if we orient ourselves based on our ground wire, the black wire, the S3 will be the ground, positive, 1, 2, and then 3. So we've got ground, positive, 1, 2, and then 3. This is the third one over. That's the next one in line. Yes, I know this is tedious and boring and awful, but this will keep you from destroying a flight controller, because failure to do this correctly will definitely cause issues with your quad. You will not have a good day. Okay. There it is. Now the next one on here is S1. So S1 is going to be right next to the red wire. So we want to make sure we've got the right wire here. Alright. That's this purple one. It is number 1. And we want to make sure we plug that in right next to the last one we did, which was this purple number 3. We want this purple number 1 to go in. That one's in. And you can kind of hear a little as it goes in. And then the next one in line is the S4. So that's going to be the very last purple one. We're going to connect that one up. Yep. This flight controller and ESC stack is kind of unique in that it's so wonky. Most of the time, the very next one we have to do is S2, and that's the very last remaining purple one, and just to confirm, it's in the second slot. Yes. And yeah, most of the time it isn't this, it's usually a little more straightforward, let's put it that way. It's not usually as bad as this. But when you're dealing with absolute cheap flight controllers and ESCs like this, now we want the TX. You kind of have to take the good with the bad. So current, which is the green wire, is the very last one, and then the yellow. The yellow wire is the arc. So we want the yellow wire to go into the next spot, and we want the little catch to go down. Click, and finally the green wire is the very last one, and it's our current wire, and it is going in last but not least. Okay, yep, Rob builds a cable. Cable is, come on, if you have trouble getting it in, tweezers help. There we go. Yeah. Well, that one was it. Okay. Sometimes they don't always cooperate. You just got to kind of force them together. There it is. That's got it. Okay. Good. Now, always a good idea to plug it in and check. So don't plug in a battery or anything else. Plug it in and check. Look at it. Say, oh yeah, the green wire is the current. The yellow wire is TX. That's S2, S3, S2, S4, S1, and S3. That is the negative. That is the positive. And that is plugged in correctly. And it runs up to this guy. Okay. Rocking and rolling, like I said. We want to find motor 4. We want to make sure it's in the right orientation. And that is that for our ESC and our cable. Next step, let's get our gummies. Come on. We'll put our gummies in this flight controller. Interesting. Yep, the flight controller is even more important to mount on gummies. It has a gyro in it, and that gyro is going to, or I should say an accelerometer. It's really a kind of a complicated instrument, but it is going to kind of tell the software the orientation of the quadcopter and help identify when it needs to make adjustments. And if you have it, if you allow noise into the flight controller from let's say spinning motors or something, if you're shaking it around a bunch, that noise is very hard for the that little computer to deal with. So the software just kind of gives up and doesn't try very hard. Alright, we are going to, let's see, this needs to come out the side, and let's figure out which way is forward. Alright, so this is forward, and this is usually the up. Alright, that's good. Yeah. Let's see if we have some small standoffs that we can use here. Crank them down just a little tiny bit. Again, just hand tight, just finger tight. Doesn't need to be He-Man tight or anything at this point. We're just mocking everything up still. Okay, we will go ahead and connect our flight controller here to our ESC before we kind of put this down on top and start soldering to it. What am I missing here? There we go. Just needed a little bit of wiggling to get it right. And this guy has an arrow on it. You can see the arrow, and it's pointed that way, and that means that's the direction, that's the forward direction. If you have to orient it some other way, don't worry about it. Betaflight can handle it. You just got to change it, and remember that you've done it. So, and we're just going to screw these guys down like so. And now our flight controller is pretty much mounted up. We're getting close here. So let's figure out our XM receiver. The way this guy gets communication from your remote control is through this guy right here. This is the Free Sky receiver, and most of your modern day S-bus 5-volt and ground. Okay, well, that's good. So what we can do, rather than running pins, we could actually just do see, the square is going to be the S-bus. So the square is going to be S-bus like that. So we came down. Ran one along the arm. I don't really like that. So what I'm going to do is I'm going to run wires. Yep. So I keep a little bucket of wires like this from previous builds, and always good to have a bucket like this. So right here we've got 3 wires, and that's all we need for this. And what we're going to do is solder this guy up and then solder it to our quad. So we've got our ground is this pin right here at the end, and we want to just tin it up. That's the 5-volt, and this is the S-bus, and S-bus is the communication bus that the flight controller will use to communicate between the two. And okay, there's one. The next one is 5-volt, so I should make it red. Down through that hole, that's in there. And finally the ground. And you can find all that in the instructions here. So the square win at this end is S-bus, then 5-volt, then ground. And you can orient yourself off the bind button if you don't want to rely on anything else. The bind button is over here, and S-bus is next to that on these XM receivers. That one's done. And we'll just give it a couple of quick twists like so. And let's see, do we have any, no. They actually didn't give us any plastic to go around that guy. That's okay. We'll make do without plastic. So we've got black, red, and white. Let's tin those. There we go. I think that's good. Yep. And we'll tin our ground pad here, our 5-volt, and our we want the RX pad. It's going to be the easiest. And you'll notice that I bridged these two pads. That's the easiest way to deal with a bridge, is just to heat up the blob and scrape scrape them off. Just nice and gentle. Doesn't need to be hard. You don't need to be He-Man about it or anything. And if you're still fighting with it, you can try using some solder wick, and that's available on Amazon for a couple bucks. Or you can make some out of wire. So just grab a piece of wire and kind of curl it up into a little bit of a mesh, because that's really all it is. Just kind of fray it out and use it almost like a sponge. Alright, next up we're going to need to wire up our video transmitter. Now the video transmitter has a couple of options, and one of those is something called smart audio, and or smart audio is a bad name for it. All it means is VTX communication, and the VTX here, it has a couple of pins. So it has the DC voltage, which is going to be, let's see, on this guy it is 7 to 36 volts. So it needs to be either run off your VBAT or run off of a 7-volt or 7.5-volt pad on your flight controller, and we'll figure out where we're going to run it. You want the DC to be your voltage and your ground to be your ground wire. SA stands for smart audio, and that is just a way to control the VTX from your flight controller. 5-volt and ground are outputs, so don't be confused by those. Those are intended to clean up signal issues with cameras that you might be having. I don't use them. A lot of people don't use them, but the very last one here is video. That is the input video signal that's going to be broadcast out to your goggles. And so let's go ahead and figure out where we're going to run this guy. And this comes with a pin header already configured for us, and all we really need to do is go ahead and, alright, so he's got this guy like so. We just want to figure out where what we're doing. Alright, plug this guy in. Like this. Alright. Video is this white wire. We've got ground and 5 volts. Okay. Those two we don't actually need. This is the ground, and this is the smart audio signal. And then there's the DC end voltage. Okay, so let's see if we can find a pin on our flight controller for everything. And just usually it's at the rear of the quad. Alright, so we've got TX and RX4, LED, 5 volt, ground, VCC. So when you see VCC, that's a good indication that it is the battery voltage. Then we have ground again, RX and TX3. So what we're going to do is connect our smart audio to the T pad, the TX pad here, and okay, the ground we're going to need, okay, and we're going to need a VCC. Alright, there's also something called VO up here, and that is video out, so we're going to need that guy as well. Uh-oh, I have just some cruft on my, there, that's better. And then we have God, I can't even see that. So there's VO, V plus, V2, yeah. Sorry, I'm trying to figure out what's what right now. It looks like they've already pre-bridged the 5 volt pad for our camera. So that's going to be, our camera needs to also be connected to our flight controller, Cam F. I can't even read the screen printing on here. It's so, let's clean that off. Good. Okay. Well, we'll get to the camera in just a second, but we've got our 5 ohm. We're going to clip this wire here. Where'd you go? Alright, so we've got these two I do not need. So what I'll do here is I'll actually, you know what, I'm just going to clip them off since we don't actually need them. Yep, don't actually need these two wires. And just double check before you clip anything, this is ground and 5 volt out, and that's done. Don't need them. Okay, now this is our video out, and then the rest of these guys are, yep, we'll tin these guys with my going crazy today. Tin these real quick. That's video. That's the smart audio. And this is the negative. And then let's go ahead and get it connected up. Alright, so the yellow wire, I'm just making sure the yellow wire is smart audio. Yes, yellow is the for whatever reason there's no standard, but yellow is sometimes used for smart audio, but sometimes it's white or green. There's that one. We want ground. And then we want 5 volt. And then we want video out all the way up here. Okay. our VTX is done. And we can kind of give it a couple of quick twists, and that'll sit right back here, and we'll zip tie that in place probably, or we'll put it on top. I don't know which yet. The next, the camera. So our camera is right here, and our camera really only needs 3 wires, though it does come with 5. And let me make sure. Let me see what we got here. Okay, here, this is our pinouts for our board, and this is the orientation that it's in. See, the USB is a good way to orient yourself. So we've got camera control, cam C, that's almost never used. Video in, battery voltage, ground, video out, the TX5, VBAT, and ground. So what we're going to do is we're actually going to use it says VBAT. I'm bringing out my multimeter because I'm curious about something. So this pad on here, on this diagram, is labeled VBAT, but the intention, I think, is to use it for the camera. Now VBAT, it almost looks like these 5-volt and VCC pads are intended for that pad. And all I'm going to do is check the continuity between that solder blob that's covering that 5-volt pad and the VBAT pad. And look at that. It's actually configured for 5 volts, not VBAT. So the VBAT means battery voltage, or voltage from the battery. That should actually say VCC. And VCC means different things. It's kind of confusing, but VCC means video from your power supply, and it's a kind of a really obscure way of doing things, but whatever, doesn't matter. We know what we're doing. So we have our camera. Our camera can actually take any voltage we hook it up to, but I like 5 volts, but not everyone does. Some people like more, some people like less. It doesn't matter to me which one you use. It doesn't matter to this build which one you use. And what we're going to do, it comes with a camera. Let's see. This cam has 5 volts, ground, video. So we've got 5 volts, ground, and video, right? Then we have this current sensing VBAT line. This is intended to connect to your battery in order to. I don't ever use this wire, so for anything, because we have flight controllers with on-screen displays. So OSD tells us how much battery voltage, and that's what we use. And then a TX and an RX. So the TX is going to be this brownish looking wire, and the RX is going to be this greenish looking wire. So let's go ahead, and we're going to actually leave these about this length, because I don't really care about the length. And we'll go ahead and we will tin up our cam C. our video in, our voltage, and our ground. The next one is ground. The ground pin is right here. And so now we have cam, video in, our 5 volt pad, which has been bridged here, 5 volts, ground, and we're actually going to connect up this TX5 as well, because I'm not sure which one is which. Cam control and TX5, and back here we ended up using TX3, so we do have a spare UART. We have TX1 for our receiver, TX5 for our or TX3 for our VTX, and we can use TX5 for our for controlling the camera. So we'll give it a shot and see if that works. Let's go ahead and get our, let's see, camera. We're going to do our, this is 5 volt. We want ground. And we want video in. And I'm actually going to add just a tiny little blob here. This guy just did not want to go down. There it is. And let's see, we want TXRX. So the green wire is going to be the receiver, so we'll connect it up to the TX. And where is you know what, we're actually going to remove this one. We're not going to use TX5, we're going to use TX4. Yeah, that's yeah. Okay. Connect this green wire, which is the RX, to the TX pad. And then this guy gets connected to the RX pad. That ought to do. Okay. Connect up our camera like so. Okay, rocking and rolling. Now, before we go much further, what we're going to do is just verify our pads. So I want to make sure that we haven't bridged anything, even though it doesn't look like we have. Okay, we're just going to go through and double check that we haven't bridged across anything here. And all we're doing is checking for continuity. If we detect continuity, we know we've got some bridging going on. And I don't see anything, so I think we're good. And we can verify this by just checking for continuity across these two pads, or the battery terminals here, and that'll tell you if you have something going on that shouldn't be. And it is looking pretty good, and we could potentially, if we connected up an antenna here, we could actually power this guy on. So this is called a smoke stopper, and it's designed to prevent you from destroying your quad if you know, screwed something up. Now, what we're gonna do, I have a little wristwatch doohickey here. Alright, and what we should see, looking back at us, is my workbench. And we're going to connect a 4S battery. So what we're doing is we're going to check to see if we get a green light here. Okay, green light, that's good. Alright, and I don't know if you can see this, but we have a working camera. Doop, doop, doop. There it is. Hi. Okay, good. We don't want to leave it plugged in too long. Always a good idea to turn everything off and finish up your build. So we did a smoke stopper check, and that's a good first sign. So that will tell you if you've got any issues at all. I didn't check our receiver, but we'll get that guy bound to our remote so that we can go test fly this thing, and I'll get these the motors installed next. But I need to take a break here. So, doing good. Build is going well. We'll get the motors on it, and then I'll film that, and I'll show you the motor install process, and yeah, we should be rocking and rolling, and ready to get some flying in. So hoping to fly it all tomorrow. We'll see. Shouldn't be a problem since everything's going so well. But that's how you put together a quad, a flight stack, and get everything wired up. Rotor Riot, in its infinite wisdom, has chosen to give us 5mm screws. You know, these are for mounting the motors, and those aren't nearly long enough, considering that the base of this, that the arms are actually 5mm thick. So, okay, the screws that came with the motors are not correct. Unfortunately, they didn't actually give us correct screws. Now, we have screws that we could probably use, these 7mm screws. I think they're 7mm. And those would probably work well, except these were originally intended for the top and bottom plates to hold it on. And for whatever reason, they only give us 15 of those. So, one of the things I strongly recommend whenever you're buying or building is pick up an assortment of M3 screws. Now they go from 4mm all the way up through 50mm, sometimes longer than that even. But a good kit will have a couple of different types, and what we're going to do is see which types we have that would work for us. And I think we're going to grab one extra of our cap head like this. This is going to be an 8mm, and want something comparable to that. and there it is, it's right there. So we've got another 8mm. So that's all 16 of our screws necessary for attaching the top and bottom plates. So we've got that covered. Now we can run an M3 x 8mm, and I don't know if you can see this. We've got M3 x 8, and then we've got M3 x 10 socket cap, and socket cap looks kind of like this. It's got the barrel shape to the end of it, and I think we actually want to run that type of screw, except we want at least 8mm, not 6, and this looks like a 6 to me. So we may need to poke around a little bit in our bin to try and find everything we're going to need, but it should be here in sufficient quantities. So there's 4. That's one motor down. We need 1, 2, 3, 4. That's 2 motors. Let's see, 1, 2, 3, and 4. 3 motors, and for this final one we may need to either scrape the bottom. 1, 2, 3, and 4. So there are all 4 of our motors. Now you'll notice this is kind of a mixed bag, and it's because after every build I just take a couple minutes and I split everything up, and I'm like, I just toss it all back in here, try to get the sizes as close as I can. But for the most part, just having access to a parts kit like this is going to be a lifesaver for when you actually need the part that you're missing, or a screw that you're missing. So that's what we needed, was something just long enough to come up through there. So if we take a look at this guy, you can see we actually have quite a bit of room before we start getting into windings. Okay, so just all the way around, you can see we're not, if we come up through there a little bit, it's not going to be a problem. Even here we've got just a couple, maybe a millimeter on top of this guy before we start getting into our windings. So when we come up through this plate, that's what we're going to be looking for. So we'll just go ahead and start mounting up our motor, and you can kind of see that as it comes through this plate, we want to just kind of confirm that we're not going to be getting into our motor windings or other windings, or wires or anything else, and that's going to keep us from destroying one of these motors, because these are actually really nice motors. They're not cheap motors. If you're going to spend a little bit of money on a first build, you want a decent, halfway decent motor, and you know, these are probably 15 or 16 bucks a piece, maybe a little more if you were to buy them separate, and they're worth every penny, honestly. I've used these in the past on another build before I started making videos on everything, and they actually work really pretty nicely for what they are. And you just want to make sure that you've got, just get a couple of them started. We're not making anything tight right now. All we're doing is getting our sorry, we're just getting our motor installed, and we'll go back and snug everything down. Once we've got everything sort of aligned right, we know that we have, you just want to make sure your wire is pointed down the arm towards the flight controller and the ESC, not out into the abyss. Otherwise you'll have to undo all the screws you did, and it's a real pain. You also want to make sure that you're on the top side of the arm. You wouldn't believe it, but I've actually goofed that up more times than I care to admit. So yeah, putting your putting your motors on the correct way is always a bonus when you can do that without screwing too much up. Alright, coming down to it, we've got one left. And he gets pointed towards the flight controller like so. And you'll notice there's a hole here. Now on the bottom of these guys, not all of them are like this, but they usually have, they stand proud of that mounting surface. Not all of them, but a lot of them do. So what you'll see in some arms is that they have a little divot. So you got to make sure that that divot is on the top side when you mount it. This has a hole that goes all the way through, but like if you're doing a Mr. Steel build using an Apex, Impulse RC Apex, that's actually an example of one where they have a divot, but it doesn't go all the way through. And you just need to be aware that you want to make sure that it's on the top side of your quad when you're doing this. Otherwise, you'll have to flip arms and undo bolts and everything else that you pretty much secured forever when you put thread locker on it. Now I don't have thread locker on any of this stuff, so it's not, because it's just it's not that important if I lose a screw when I'm out on a flight. You know, it's always a good idea to check everything and bring it in. And we're not going He-Man tight on anything, we're just snugging it down. I'm not trying to break these off. And our last one. Okay. I am actually going to install some of our front mounting hardware, because the camera flopping around like this is kind of bugging me. Having this front mounting hardware up here will let me mount that camera so it's not flopping around on me. And the way it gets mounted is with these little blue gummies. And these guys, like with everything in quads, are 3D printed, and they're flexible. And the way these guys hold things is they go down over top of these posts, and your camera gets screwed to the your camera gets screwed on like so, and then it sits like this, just back slightly, and boom, works pretty well actually. So we will kind of snug this guy over like so, snug this guy over like so, and then we'll get a screw to go through that. And this camera cage here contains a couple of screws, and the longest ones are probably the ones you want, because this gummy material is pretty thick. And then we take our screwdriver and we poke it all the way through. Then we lift up the cam. And snug it down. Again, doesn't need to be He-Man tight. It's not that heavy, so don't go crazy with it. Okay. And on the other side, you do exactly the same thing. You just screw it in and just snug it down just a little bit. Okay. And then use your thumbs and work it down. There. And you want it about midway down, give or take. And that should do it. Now, we probably could have gotten away with using these shorter ones, but I think that these longer ones will keep the camera back enough so that it doesn't end up getting bonked in a crash. But, you know, the choice is probably up to you as to which one you want to use. You know what? I think I will take this off. I think I'll switch it now that I've looked at that, and now that I see how far apart it is, or far away it is from those uprights. Only takes a minute. Just take your time. That one. Ooh. Oh yeah, I like that a lot better. Yep. Every once in a while you goof and you're just like, oh well, just roll with it. But this time I'm glad I changed it out. I think that works better. Yep. And it's still fully behind those uprights, and it's not going to cause any problems, so I'm confident that I made the right decision there to get that situated the way it is now. Yeah, that was definitely the right call, because these were just sitting back too far and you would have seen nothing but post in your image coming off there. And we'll clean up these wires, don't worry. We'll put some twists and everything once we're like so. If you just need to clean up a wire quickly without resoldering anything, just twist it. Works great. Don't twist too hard now. Just get it nice and compact. There. Now you got plenty of wire to work with. Good. Camera is secure. Now let's go ahead and solder up our motors. we'll put these little guys into a little baggie. Okay, and we don't really need all of these anymore. Got everything we're going to need. Right there. I think that's it. Yeah. I'm just tucking everything away in case I ever want to come back later and do anything with it. I've got everything kind of set aside. All right, good, looking good here. Now, these guys, the conventional wisdom is you wire up 1 and 4. I'm sorry, you wire up, let's see here, it's 1, 2, 3, and 4. Okay, so 2 and 3 tend to get reversed in you tend to have to reverse them. If you don't want to have to do that, you wire them up with 1 wire crossed over, and that's how I'm going to wire it up here, and we'll see if it works out in Betaflight. If not, you know, no problem, we just have to reverse everything. But for the other two, you just wire them direct, right? You just go 1 to 1. Okay, and that's just the nature of wireless motors, brushless motors. All right, so we're coming up, and what I like to do is come along and just kind of give it about an extra 1/4 inch, maybe not even that, and snip it off, and then that's going to be that one. And then the next one goes to the middle one. Bring it along about as straight as I can get it. Nip it off. There's that one. And finally, this one. Okay. And we'll tin these real quick. And that's 1, 2, 3. Now, here I'm going to take this guy and solder it to this pad. Just like, see that little wire hanging out? You want to avoid that hanging down. All right. One. Now we're doing the middle one to the middle pad. Finally, the last one to the final pad. Okay, there are the motors, or there's the motor number 1. So motor number 2, what we're going to do is swap these 2 wires right here. So when we go to solder it up, we're going to make sure that we're not, we cross one over the other. Let me double check, come up, and then there. And then this one comes to the end. Okay. and then this one right here comes to the middle. And there's no reason to save any of these. I just don't pitch them as often as I should. 10 are wires. Let's try and keep all the little strands nice and close. Otherwise you just end up fighting with them later. Alright, we want to grab our tweezers. We're going to grab the middle wire and we're going to run it all the way to the end. That's our first one. Let's clean off our tip. What do you say? And now we're going to take our end wire and we're going to run it right to the middle. And then our final one, our first one, goes to the first pad. Not all flight controllers are like this, but for the most part you can bet on it pretty much working out this way. I am just gonna redo this one because I didn't like how it looked. There. Okay. Number 2. Done. And we'll tape these down to the arms because I prefer to just keep it simple. Tape works great. And 3, this is number 3. This is the front of the quad. So it's 1, 2, 3, and 4. So 2 and 3 are the ones we're swapping the wires around on. So we need to make sure that we do that. And we're going to bring this one all the way over and bring it up. And right about there. We're going to take this one, the middle one, and run it to the end. Very last spot. And then we're going to take this one and run it to the middle. And we're going to tap. Okay, let's go with we want the middle one, and we're going to run it right to the end. Middle one goes to the end. Yeah. Okay. This one goes to the second pad, the middle pad. And this one goes to the first pad. Good. Rocking and rolling here. Let's get rid of all of our garbage as we go. Always a good idea. This one, we can just wire it straight, just like we did number 1. Okay, coming along, come up, right about there. Come along, come up, right about there. Come along, come up, right about there. And then we'll tin these guys. Good. All right. Let's take this one. Go to number 1. This is the first wire. And we'll take the middle wire. And go to number 2. And then we'll take this final wire and go to number 3. All right, that should be that. Now, this is the XM Plus. It requires a Free Sky receiver. Here is my battery pack. Let's go ahead and get our model set up. All right, so simple model setup for this guy is come down here, we create a new model. We're doing a multi. The default TAER is usually what I just use. T, R, P, and Y, enter. Yep, and then exit page. We want to call this one the CL CHEAP. And we are going to use D16 mode, which should be the default. And there's D16, and there's our range, and we're going to put it into bind mode. And this is the trickiest part, and they actually make like a little switch, makes this a whole lot easier. But these guys here have this bind button that you need to hold down when you power on the device. Otherwise it will not work, and we need to do that. So easiest way is probably holding it down. Good, it's in bind mode. We're going to click the bind button, and we'll just do channel 1 to 8, and it should start flashing. And I don't know if you can see that, but it's flashing now. And now that it's done, we just stop, we unplug, we exit, and we come back in, and when we plug in, it should go green, and it does. Yay! We've now bound our quad. Now in Betaflight we should see all that. when we finally get it over there. But we've got some more stuff we need to do. But this was kind of the next step before we button up our frame, and I put some, you know, shrink wrap on this guy. Yeah, we wanted to make sure that we were good to go before we did any. And we should probably go ahead and page over here and add a arm switch. So I just call this A for arm, and then exit and come down. I like my arm switch right there, so switch A, and then exit and exit, exit, and then the final one I like is my this guy right here. This is going to be our flip over after crash, and so I just do F for flip and exit, and I come down here and flip that little button, exit, 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 and then we go to the next screen and we have to say our output channel 5, and then you don't have to change anything at all, you just exit and it creates it for you, and then exit. And so our arm A and our flip over after crash will be on that one. So these other switches aren't used for anything on this particular quad. And I'll turn this guy off. Done. So we have video, we have our working, not Crossfire, our working XM Plus, and our camera. So we know we've got most of our kit working. It's actually time to start wrapping up. And so for the arms, I just like the simplest possible solution. For me, that's tape. And actually, before we do that, here's what I'm going to do. This is called Kapton tape, and it works instead of shrink wrap to kind of keep electrical components isolated. If you can find the end of it. If you can't find the end of it, you just throw the thing away. And I'm kidding. Doesn't take much. It's super thin, super light, works like a champ. So I sandwich is how I tend to do it. So I just take this guy now and fold it right over on top of the other one, and then I come along and I go, and that should keep us electrically isolated from, well, everything else. Should, mind you. And then we can give this a couple of quick twists to just kind of keep that nice and tidy, and we'll stick it right back there. Now one of the things that comes with the kit is this little guy. He's got 2 antenna tubes. Now one of the things I didn't actually see in this kit was an antenna tube, and as far as I can tell, it's not in the box, so I don't know what happened to it. But either maybe I took it out and just set it aside, and I dropped it or misplaced it. Oh, look, there's a screw. Yeah, who the hell knows? But yeah, that is one of the things to that you may need to supply. And luckily, I have 2 right here that will work for this. Right there. Oh, come on. Get back in there, you piece of shit. There we go. And so the rush tank can actually be mounted directly to your carbon if you want. There doesn't, I don't think, yeah, there's these little raised grounding pads, so you can actually rest it on there, but I'm going to put some sticky tape underneath, and this is just your typical servo tape. You can buy this on Amazon for a couple bucks. I think it's $4 or $5, and what this tape does is it cuts down on vibration, but it also keeps you electrically isolated to some degree from your underside. And we'll just stick it right on there like so. Get that little end off, and then we will kind of give it a couple of twists and then stick it right there. Is that good? No, that is not good. Yeah. Ugh. Good God. I think it's longer than I remember it being. I'm trying to make sure that our uprights here, our standoffs, aren't going to interfere with the buttons, and it looks like it might. I may need to set this in here a little bit. Wow. Okay, I guess that's a little funky. Let me show you what I mean. This guy here is really close to that button. I don't like that at all. I don't remember this being a problem, but we'll just make sure our standoffs work. Well, yeah, shit. We may have to do something different here. You may have to set this guy up on top, or yeah, that's weird. I thought for sure that rush tank wouldn't be a problem fitting there, but now that I'm looking at it, it kind of looks like it might be. Let's get our stuff in first, and then we'll all right. Yeah, this guy just doesn't want to. Oh, there we go. I just needed to move it further back. I'm an idiot. That's all it is. Yep, just an idiot. I just had to move it back far enough, and sure enough, it went right in without any issues at all. Big idiot. Yeah, that looks so much better there. Yep. And then this guy, what we'll do with him is we'll route him around this cord. We'll just give him a couple more twists, and then we'll put him right on top, right there. And for that, we just need a little tiny bit of our tape. And he will be good to go right on top. Okay, out like that. Boom, done. This guy comes down. Like I said, they give you this little printed TPU part, and come bring it down like so, and then we'll get this lollipop situated. Let's bring it all the way down. Yep, that's all the way down. Now, this guy needs to go into there. And that's going to need just a bit more. Oh, shit. Bit of finesse, actually. There, done. That's all it took. Just needed to get it lined up. You can kind of see there, all lined up. And these guys can each go out one side and the other. So that's the kind of the nice thing about the XM Plus, is that you got one wire for each of these little holes. What I'm talking about here are these guys, and let's see if I can find them on the inside to route this wire through. Oh, come on. There's the one, and the other one. It's got the exact same hole, and we just need to get it started. We can grab it and pull it out gently, and then we can slide our antenna tube down over top. Like this. There we go. Hopefully that won't get in the way of anything. But yeah, that's not too bad. Not too bad at all. I like it. And the final two uprights go here behind the camera. I call them uprights, but they're standoffs. You know what I'm talking about. This guy kind of gets tucked in like so, and our top can go on. Yes. Yeah. Okay, sure. So this opening is just not big enough for the wires we have to run in that direction. So when you have something like that and TPU's in the way, just clip it out. Ain't gonna hurt nothing. TPU is not structural, it's just meant to hold things, really. If it's preventing you from getting something done, just dig it on out. There's that one. There's that one. Now this wire should sit in here just a little bit better, I think. Or maybe even that should do. Yep, that ought to do it. Alright, so we got everything nice and tidy and tucked in. Let's get our arm wires taped up. Start on the back of the arm. Okay, you want to be about the middle of it. About the middle. And just come around 2 or 3 times. And then pull it clean. And you can trim up this torn edge if you like. I usually come through and and that'll keep those wires from flopping around or getting hit by the props. And then come over here, strike off whatever, and then next one, come down to about the middle, stick it to the back, start looping. There we go. Start in the middle. Alright, last one. With electrical tape, just a little bit of tension does the trick. Pretty happy with that. I don't see anything that I'd change really. Alright, now let's figure out our that's the strap they give me. Okay. Yeah, I guess it'll work. Let's get started at the rear. One and two. Get them started anyway. Now we'll kind of make sure we're not pinching this cable because we don't want it to cut through. And you know what? I actually don't like it already. This carbon is just a little sharp, and the easiest fix for sharp carbon is to sand it down just a little bit. And just use a little file. This is the bottom side, this is the top side with the CL1. If you don't want to see that, put it towards the bottom. And what I'm doing here is I'm just taking my file off the edge of my bench here and grinding it down. Alright, now it's rounded over, so it's not going to cut through that wire, not unless there's an impact or something else. Yeah, this build has turned out pretty well, actually. Not gone too bad for about a 2-hour build, all said and done. When you're looking at the clock, anyway. Of course, I have experience and I've done this before, but don't get discouraged. If it takes you 5 hours or 6 hours or 6 weeks, just, you know, take your time, go with it. You know, try and focus on getting one thing done. You know, you've got pretty simple, pretty basic configuration of this guy, and yeah, should go pretty much according to plan. And that is gonna do it. Now the nice thing about the CL1 actually is that I have a mount for it, because I already have a CL1, so I'm going to attach this mount. Actually, I just remembered, that way I can take some video of this particular build, but you don't need to do this for your build. I just want to get some run cam footage from it, you know, something other than the goggle video. But yeah, it should work just fine without this. And this is just a TPU print, 5% infill. You can find this on Thingiverse. Just Google CL1 mount Thingiverse, and it'll come right up. Probably your first hit, and you can find most mounts for all your quads that way, just by googling, you know, mount frame name, GoPro mount, Thingiverse. Those keywords will probably get you exactly to the STL file you're looking for, and then you can print it out and be on your way. And this one actually printed out just fine. This came from my Prusa okay, well, that one might be stripped. There we go. Just needed a little press. And that's it. That's going to go flying. Yep, the CL1 is a fairly straightforward frame to build. Doesn't need a lot of complicated engineering. One of the things that you could add to this build right away, if you're a new flyer, is a buzzer. And a buzzer is going to help you find it if you lose it in the field or something like that. For me, when, you know, I find that I have a hard time hearing the buzzer no matter what, or identifying it based on, you know, what it's doing. I actually think arming it is one of the easiest ways to figure out where something is, because if you arm and it's upside down, it's going to throw grass up in the air or dirt or something up in the air, and chances are it's going to be fine afterwards. And so that's how I tend to find things. But you know, you do it whatever way works best for you, and that's how we do the CL1. Now the CL1 also comes with grip. This stuff is fantastic, and I'll show you why in just a second. The you want a piece. Oh, you know what? This is going to be the perfect size, probably right about there. We're going to move this in about that far, give it a little snip, and then we'll come and we'll say, just like that. That's all you really need. Yeah, I really like this stuff. In terms of getting batteries to stay in place, you know, I have a battery right here, and I'll show you just exactly what I mean. So when you go flying, you're going to stick your battery on there, and then, oh yeah, it's not held on by anything except that what's called sorbothane, and it's really a brilliant material for holding this in place. And you don't need to put Velcro on your stuff, don't need to play with it. It works really well. That's why I'm a big fan. And it's grip, Tommy, whatever, I'm a god. He pioneered the use of it on his quad and made a business out of it, so I buy it. And that's it in a nutshell. We can put our GoPro up here, kind of wrap it up. And there's the GoPro on top, ready to go. Let's check our all-up weight. I know that's important to some people. One of the things, I guess, that they didn't include in my kit were props. Or they did, and I took them out at some point. Yeah, that's a little weird, I think. If you're shipping a kit, you know, save this stuff. It's great. If you're shipping a kit, you might want to include props, although, again, like I said, if I took them out already, I apologize to the folks at Rotor Riot, but for me, having a good pair of or a good set of props that you know is going to work with the quad is somewhat important for me anyway. I think, and put it away as silver tape, and you know, it doesn't. They don't need. They're like $3 for a good set, and you know, maybe $4 for a really good set. So on this guy, with the weight that we're working with, I think. I think these will work. These are 5045Cs. They the Dow Cyclones are pretty good. They're not too bad. Should make for reasonably smooth flying with this power level. Now you can go. Prop choice really is a subjective thing. So it might fly like shit. It might not. You never know until you actually get it out there. And that's kind of what I tell everyone. You can try and make a database of prop stuff, but without... I'm just going to set these on here. I like to run props out. Not everyone does, but I you know, on this quad, I think I'm going to run props out. I don't see any reason not to. Especially because I fly in a place with a bit of scraggle, and this time of year it's all ghost branches. So you know, if you this one and this one, sorry, takes a second to concentrate on that. Yeah, so you know, if you want to stay, if you want to be able to, if you want to be ghost branch tolerant, you know, that's one of the things that you need to do, is set up for props out rotation. And all that means is that if you imagine this is the center line, these props rotate away from the center line, and these props here kind of rotate towards the center line and back. Or if you think of this being off the back, out, away. Yep, and these rotate out away. The normal way is to rotate inwards, and that's okay. But what happens to a branch is, if you imagine you're flying along and you hit a branch, it ends up getting stuck right there, and then your quad ends up tangled in a tree. And this time of year, without any leaves on things, all you have are like these little branches sticking up in the air, and you're done. Anyway, all up weight. Let's get our all up weight. You don't need to hear any more about me rambling on. All up weight is going to be 700 grams, and that's with a GoPro and a 4S battery. Now this 4S battery isn't like the greatest thing ever. It's a 1550, but yeah, 709 grams all up weight with a GoPro. Now if you're not running a GoPro, and I imagine that there are people out there that don't, if you're not running a GoPro, and keep in mind this mount, maybe 10 grams, give or take, you're talking about 580 grams, right around there. Props change it, batteries change it. Like, not all 1550s all weigh the same, not all 1500s weigh the same. It's just, it's all over the place. So right around 600 grams is a really good spot to be in without a GoPro. With the GoPro, you're over that mark, but hey, for a $200 quad, that's really good. All right, the next part, all flight footage. So hopefully, I won't be back on the bench for anything. We've tested everything. Only thing we need to do is take it over to Betaflight and get this configured. And if you have questions about that, I strongly defer to Joshua Bardwell, just because he is the expert on making videos that target exactly the thing you're trying to figure out. So focus on his videos for that part of this. If you want to see somebody just doing builds all day, come to my channel. His channel has builds too, but he teaches you something, and all I do is ramble on while I build things. So, all right. Thank you for watching, and stay tuned for a flight video.